Hello students, now I will discuss Cambridge A-level chemistry May June 2022 paper 52 paper 5. Please subscribe, like and share my channel. Let's move. Here you see magnesium metal reacts with hydrochloric acid to produce magnesium chloride plus hydrogen. You are given magnesium ribbon, 0.5 mole per dm hydrochloric acid, water trap, conical flask, measuring cylinder and electrical balance. This students procedure, this is the procedure. Step 1, prepare the pitch of magnesium ribbon for the use in the experiment. Step 2, measure 30 cm cube of hydrochloric acid and pour into a side arm conical plugs. Step 3, attach the conical plugs to the collection system for the hydrogen gas. 4, place the magnesium ribbon in the plugs. Stopper the plugs. This is the procedure, and wait until the final volume of gas has become constant, fixed value. Step 7, wait for an extra 2 minutes, then measure and record the final volume of the gas. This is the procedure. Now you see A, show how the apparatus should be assembled for the collection and the measurement of gas. That means this flux is given, so you will take an water trough, take water, this is delivery tube, then one measuring cylinder inverted. Measuring cylinder has mark, so this reactant, this gas will collect through the water and this gas will be collected here. As this hydrogen gas is not dissolved in water, so this gas will be collected over water. This is the gas collected, and this apparatus is known as measuring cylinder. These 2 marks you will draw and label: gas collected and measuring cylinder, you will label. Next, B1, the surface of magnesium ribbon has an oxide layer. You know, magnesium reacts with oxygen, so magnesium oxide layer is formed. Now state how the student should prepare the pitch of magnesium ribbon before it is used in this experiment. To remove magnesium oxide layer, remove oxide layer by using sandpaper. By using sandpaper, oxide layer on magnesium has to be removed. 2. State what additional information about the magnesium is required before the experimental is performed. So you have to take mass of magnesium, how mass of magnesium has been used in this experiment, so you need to take the mass of magnesium. Then C1, show by calculation that the volume of 30 centimeter cube 0.5 mole per dm cube hydrochloric acid is enough to react with 0.16 gram of magnesium ribbon. You have to show your working. Now you see hydrochloric acid concentration and volume is given, so you can find out moles, number of moles, and also magnesium ribbon mass is given, so you can find out mole. Now this means 30 centimeter cube hydrochloric acid is enough to react with 0.16 gram of magnesium. Now you see first mole of magnesium used, concentration into volume, 30 centimeter cube divided by 1000, you have to convert it dm cube. This is the mole of hydrochloric acid used. So hydrochloric acid 2 mole, magnesium is 1 mole. Magnesium will be half of hydrochloric acid, so mass of magnesium needed, this divided by 2, this is the mole, then number of mole times molar mass. Magnesium relative atomic mass 24.3, so magnesium will be needed 0.18 gram. But magnesium has 0.16 gram, so here magnesium need 0.1 gram, but magnesium has 0.16 gram. Here magnesium is the limiting reagent, so for 0.16 gram of magnesium, 0.15 mole of hydrochloric acid is enough. Here acid is excess, mole of acid is excess, so magnesium is the limiting reagent. Why? Because all magnesium should be react. Now number 2, state why it is not necessary to use a burette to measure 30 centimeter cube of 0.05 mole of hydrochloric acid. You know, burette is more accurate to measure the volume, but here acid is excess, so to measure acid accurate volume is not needed. That's why this is not necessary, because a mole of acid is in excess. Next, the student waits 2 minutes before taking the reading of the volume. Suggest why the student waits for 2 minutes before measuring the volume of the gas in step 4. So to make sure that the gas at room temperature, because volume of gas vary with increasing or decreasing temperature. Volume of gas will be different at different temperature. So student wait to get volume at room temperature. at a certain temperature. Now you see E, the student collects 140 centimeter cube of hydrogen gas during this experiment. Number 1, calculate the percentage error in collecting the hydrogen gas. Show your working. So, you know, measuring cylinder uncertainty is plus minus 0.5. So, uncertainty may be to positive side, also may be negative side. So 0.05 times 2, that will be 1. That's why 1 divided by 146 into 100. So you get 0.68% error. Number B, calculate the volume of hydrogen gas using the student's result from this experiment. Volume of gas. Calculate the molar volume of gas. Now you see how you can calculate. First, moles of magnesium mass divided by molecular mass. This is the moles of magnesium. So you know, mole equal volume divided by molar volume. Molar volume. So molar volume will be volume divided by number of mole. Volume is 146, number of mole this. So we will get volume of this. Molar volume you will get 22,174 centimeter cube. This is the molar volume. Number of mole equal volume of gas divided by molar volume. So if you substitute molar volume will be volume divided by number of mole. Volume divided by number of mole. You get this value. Okay, now F. The student's experiment value for the molar volume of gas is lower, volume is less than the value of the quoted in the table of important values, constant and standards on page 11. Suggest one experimental weakness that might lead to this outcome. That means volume will be less Y. Explain how the method could be improved to overcome the weakness you have noted. Experimental weakness: loss of hydrogen gas before the flux is closed. Loss of hydrogen gas before the flux is stopped. Before flux is closed by stopper, so hydrogen gas will be lost. This is the weakness. And improvement you will have to do: ensure reactants are separated within sealed flux before mixing. That means before mixing, reactants has to be separated in the closed sealed flux. then in that case the gas will not be lost and your procedure will be improved. Come to next question. Here hydrogen peroxide break down water and oxygen. A student plans to carry out investigate how the temperature affect the rate of the decomposition of hydrogen peroxide in the presence of aqueous potassium iodide. Temperature how affect. Now experiment 2 to 8 solution are heated to different temperature before mixing the measurement. Now the data collected is used to determine the value for the activation energy of the decomposition of the hydrogen peroxide in the presence of potassium iodide. Now number A, state the independent variable. This is the temperature. Now 2B, state two variables that must be controlled, need to be controlled. You know, you have to volume of H2O2, volume of hydrogen peroxide, and also you have to control concentration of H2O2, or you can write volume of Ki, volume of potassium iodide, or concentration of potassium iodide. Next, C1, state how the student should prepare 2 centimeter cube of 0.1 mole per dm cube H2O2 hydrogen peroxide from 0.5 mole per dm cube of H2O2. Student have to prepare 0.1 mole per dm cube volume 250 from more concentrated, means 0.5 to you have to prepare 0.1. I mean you have to dilute 5 times diluted you need to do, and calculate the minimum volume of 0.5 mole of hydrogen peroxide required for the preparation of 0.1 mole per dm cube hydrogen H2O2 solution. Give the name and capacity of any key apparatus which should be used. Write your answer as a series of numbered steps. So first your volumetric plugs to 50 centimeter cube. So concentration will be diluted 0.5 to 0.1, 5 times dilute. So if you take 50 centimeter cube into 5 times dilute, your solution will be 250 centimeter cube and concentration will be 0.1 mole per dm cube. So first using a pipette, 50 centimeter cube of H2O2 solution is transferred to a 250 centimeter cube volumetric plugs. Then the plugs is made up to the mark with distilled water. If you made up to the marks, then your solution volume will be 250. Your solution will be volumetric plugs. First you transfer 50 centimeter cube 0.5 mole per dm cube H2O2, you transfer here. After that, by adding distilled water, the solution made up to the mark. So as 50 centimeter cube become 250, it has become 5 times dilute. So now concentration will be 0.5 to 0.1. This is your procedure. Next, number 2, hydrogen peroxide cause the eye and skin irritation. State what precaution should be taken when preparing the solution in CO1 other than gloves. Other than wearing goggles, what precaution should be taken except wearing goggles? So you can use using chemically resistant gloves. This is the precaution. Then next, here some experimental result, experiment number, their temperature, this Kelvin converted 1 by T. This how you do it, 1 by T. 1 by T means absolute temperature, so 1 divided by 293, you will get this value. Then 1 divided by 298, you will get this value. 1 divided by 303, 1 divided by 308, you get 1 by T, all these values you will get. Now then initial rate is given, rate. Now log initial rate, if you put here log in calculator, log this value, you will get -524. If log this, you will get this value. Log this, you will get this value. In this way you will get all these values. Then and you see, plot a graph on the grid to show the relationship between log initial rate and 1 by T. Use a cross to plot data point. Draw a line of best fit. So if you plot these values, you will get this graph. This is the log initial rate, y-axis, and x-axis will be x-axis will be 1 by T. So you will give this cross all values, cross values, you will get a straight line. After that you can find out gradient, any two values, you can find out dy by dx. Then you are asking number 3, circle the point on the graph you consider to be most anomalous. Suggest one reason why this anomaly may have occurred during the experimental procedure. And you see, you anomaly from graph, you see anomaly values, you got here that means you guess value is more. So why this value? The recorded temperature is higher than the actual temperature for that of readings. You got larger value, that means temperature will be higher. Now next you will get a straight line, then any 2 point you can calculate gradient, larger gradient in this way. Here number 4, determine the gradient of your line of best fit. State the coordinates of both points x value and y value you used in your calculations. These must be selected from your line of best fit. Give the gradient. So from graph you will get one coordinate, another coordinate. This is the x, y, this is the x, y. So now gradient equal dy by dx, you know, dy by dx. This y, this value minus this value, you will get dy value. Then dx, this value subtract this value, you will get dx. If you calculate, you will get 2931 or 2930. This is the gradient values, dy by dx. Then initial rate equal constant minus EA by 2.303 RT. Here gradient equal minus EA by 2.303 R. So if you put the values of gradient and R values, you will get the EA. You will get activation energy by putting gradient value and R values. R values you know 8.31 and gradient already you calculated earlier. So if you put this value, you will get activation energy. This joule per mole, if you divide by 1000, then you get the activation energy in kilojoule per mole. Now you see number E. It is not possible to repeat the investigation, to repeat the experiment. State whether the data from the investigation is reliable or not. I mean, this result will be from the data reliable or not. Justify your answer. This result is not reliable, so answer no, because there is a anomalous point on the graph. You see there is a on graph there is a anomalous point, so the results is not reliable. That's why you can write is reliable? No. because there is an anomalous point on the graph. Okay, thank you dear students. Please subscribe, like and share my channel. Thank you.